Hi there, welcome back. This is a video for Math 8, and we're going to be talking about Unit 8, which is a unit about congruence and similarity. Okay, so Section 1, we're going to be talking about this thing called transversals. So our objectives today, we want to determine angle relationships created by a transversal line intersecting two non-parallel lines, and find unknown angle measures created by a transversal intersecting two or more non-parallel lines. So the definition of a transversal, okay, a transversal is a line or segment that intersects two or more other lines in the same plane. So if I have two lines here, line A and line B, if I draw in another line, we'll call this line C, this is a transversal. Okay, and the reason why it's a transversal is because this line intersects two other lines, all right? So knowing this, all right, we're going to be talking about this for the next couple of sections, and it's important that we understand the different parts that are associated when we have two lines that are cut by a transversal. Okay. So the first thing that we have is we have what are called interior angles. Okay, so interior angles lie between the 2 points that are crossed by a transversal. So here are your two lines, A and B, and then you have this new line here, line T. This is your transversal. And when you have two lines that are cut by a transversal, what then is created is you have 8 angles that are created, okay? Now, if we're talking about interior angles are, again, lie between the two lines that are crossed by a transversal. So what I'm going to do is I'm going to come in here and shade this area in here between my two lines, okay? And I'm going to call this the interior, okay? So this is my interior. Okay, and if we're talking about interior angles, the angles that are formed on the interior portion in between my two lines are going to be angle 4, 3, 5, and 6. So interior, the angles that are in the interior are going to be angles 3, angle 4, angle 5, and angle 6, okay? So, now we don't all, just because we have interior angles that lie on the inside, we have specific things about interior angles, okay? And one of those is called alternate interior angles. So alternate interior angles lie between the two lines crossed by the transversal and are on opposite sides of that transversal. So we remembered that angles 3, 4, 5, and 6, these angles here are on the interior of the two lines, okay? But if we're talking about alternate interior angles, all right, then those angles would be 4 and 6 and 3 and 5, okay? So we have two pairs of alternate interior angles here, all right? So if we want to list those, we would say angle 4 and angle 6 and angles 3 and angle 5 are alternate interior, okay? Are alternate interior angles, okay? And all we're doing, guys, in this first page is we're simply just naming things, okay? So, while you may just be going, okay, what are we talking about or what are we doing? All we're doing is we're saying, all right, if we have the scenario where we have two lines cut by a transversal, all right, you have 8 angles that are produced, okay? And all we're trying to do is to name and classify the types of angles that exist, okay? The first one, we have interior angles and specifically alternate interior angles, okay? Let's take a look at the next page. Okay, the next set kind of angles are called exterior angles. So exterior angles lie outside the two lines that are crossed by that transversal. So let's shade in this area here, all right? If we're on the outside of the two lines, okay, this area here is called the exterior, okay? All right, and the angles that are associated would be angle 1, angle 2, angle 7, and angle 8, okay? And so alternate exterior angles are going to be exterior angles that are on opposite sides of the transversal. So what I want to do is come in here and say, all right, well, I've got the pair of angles for 1 and 7, and then 2 and 8, okay? Not only are they on the exterior, but they alternate on either side of the transversal, okay? So alternate exterior angles, let's list those. So you've got angles 2 and angle 8 and angles 1 and 7, all right? And these are alternate exterior angles, okay? And that's that. All right, the last kind of pair of angles that we have are called corresponding angles. Okay, corresponding angles are on the same side of the transversal in the same relative position to the lines crossed by the transversal. So if I come in here and I look at this picture, what I'm looking for is I'm just going to start with angle 1, okay? Now, angle 1 is in the top left corner of this intersection, okay? And so if I were to correspond that with an angle down over here at this intersection, that would correspond with angle 5 because it's in the top left. Now let's take a look at angle 2. Angle 2 is in the top right. Now, in this intersection, the one that's in the top right is angle 6, okay? The next one, let's take a look at angles 3. Angle 3 is in the bottom right corner. And so the one that corresponds with that over here is angle 7. That's in the bottom right. Angle 4 is in the bottom left, and that corresponds with angle 8 that's in the bottom left. So let's write these out, all right, that these are corresponding angles. So angle 1 and angle 5 are corresponding angles, okay? Angle 2 and angle 6 are corresponding angles. Angles 3 and angle 7 are corresponding angles. And then angle 4 and angle 8 are corresponding angles. Okay, so these are corresponding angles, right? And all we're trying to do is just name these and looking at them and knowing when they say, all right, I want a pair of alternate exterior angles. Well, what do those look like? Where would those be? Okay, we're given one angle, identifying what those are. And so let's do that down here. Let's identify these angle pairs. And so what I want to do is take a look at this. And this is two lines that are intersecting. And so you can think of this when you have two pairs of intersecting lines, that they're all considered transversals to each other. Okay, so on this example, what we want to do is we want to identify each of the following angles. So I want to identify angles that are alternate interior angles to angle 4. So here's angle 4. Let's first find where that angle is. It's right there, all right? Now, using line B as a transversal, the other alternate interior angle to angle 4 would be angle 13, okay? And the reason why is because it's on the interior, in between the two lines, and it alternates about this transversal here. Okay, now if we look at something else and we say, okay, well, B and A, alternate interior angles here, it's going to be the other angle 5, okay? And so angle 5 is not only on the interior, in between the two lines, but it's also alternating and it's on the other side of the transversal C. Okay, so what I want to do is just list those out. And I would say that this angle 13 is an alternate interior angle, and angle 5 is also an alternate interior angle. Okay, now the next one says two angles that are alternate exterior angles to angle 12. Okay, so with 12, all right, let's take a look at 12. This one's a little tricky. Okay, so taking a look from that perspective, all right, what I see is I'm going to use this as my transversal first, okay? So if these are my two lines, all right, 12 is on the exterior, okay? So the exterior is here and here, looking at lines C and D. Now, the alternate exterior angle would be, here's angle 12, and that's going to be an alternate exterior angle to angle 5, okay? Because that's also on the exterior here. All right, this is the interior, here's the exterior. So 5 and 12 are going to be there. And then also, so here's angle 12, here's the interior. Let's look at B and A and D as our transversal. And so 12 is an exterior angle. The opposite or alternate exterior angle would be angle 13. All right, so it's weird that we're actually getting the same thing for both of those. So angle 5 and angle 13 are alternate exterior angles to 12, okay? And what's interesting, well, let's not do that. I'm not going to talk. Let's just continue on. Two angles that are corresponding to angle 14. So here's angle 14. All right, so here's that. That's in the top right of this intersection point down here. Okay, so looking as B as my transversal, the angle that's in the top right of this intersection would be angle 2. Okay, so that's going to be corresponding with 14. Now looking as D is our transversal, angle 14 is in the top right of this intersection. Looking over here, that would be angle 10, would be my corresponding angle. So here, this would be angle 2 and angle 10. Okay, now within each of these, you have these specific angles that are called vertical and supplementary angles, okay? So what I want to do here is vertical angles are opposite angles formed by two intersecting lines. So let's just look at this, this figure here, okay? And I've got angles 1, 2, 3, and 4, okay? Now, if I'm talking about vertical angles, these are angles that are going to be across from each other. So angle 1 and angle 2 are going to be vertical angles. They're directly across from each other. They're not next to each other, okay? And also, you have angles 3 and 4, all right? So the one thing that we know is that vertical angles are always congruent, all right? So if I look at this, I would say that angle 1 is congruent to angle 2, all right? And I would also say that angle 3 is congruent to angle 4 because they are vertical angles. This is going to be true for any pair of intersecting lines, okay? Now, the same thing would happen with 5, 6, 7, and 8, all right? So if I look at 5, the one that's across from that is angle 6. If I look at angle 7, the one that's across from that is angle 8. So what I have here is I have angles 5 is congruent to angle 6. I also have that angle 7 is congruent to angle 8, all right? So given this picture, I know that this is going to be true, okay? All right, the next one is supplementary. Now, supplementary is a word that is going to reappear all throughout your math career if you're talking about geometry. So these are adjacent angles, share a common ray and vertex with no other points in common, okay? Supplementary angles are two angles with measures that sum up to 180 degrees. So one thing that I say here to talk about what a supplementary angle is that they are next to each other and they form a line. Okay, so two angles that form a line. And so what I have here is I have like angles 1 and 3 would be supplementary angles here. Okay, the reason why is because they are two angles. So I have angle 1 and then I have angle 3. They are next to each other and they form a line. Okay, so angles 1 and 3 are supplementary. Now, when they say that they have a sum to 180 degrees, that means that I could take angle 1 plus angle 3, and that's going to be equal to 180 degrees, okay? This is an equation that you're going to use a lot. Two angles are going to add up to 180, okay? Now, I could also say the same thing about angles 1 and 4, all right? Angles 1 and angle 4, those also are next to each other, and they form a straight line, okay? Here's that line that they create, all right? So angles 1 and 4 are also supplementary, therefore they add up to 180 degrees. So angle 1 plus angle 4 is equal to 180 degrees. Now for time purposes, I'm not going to go through all of these, okay? But you could say 2 and 3 are supplementary, and that 4 and 2 are also supplementary. You can say 5 and 8, 8 and 6, 7, 6, and 5 and 7. All of those are supplementary. So you have 8 pairs of supplementary angles here that you can use, okay? So that's what we're doing here, all right? So I'm not going to write down all of them, but I could write down that 5 and 8 added together, angle 5 plus angle 8 gives you 180 degrees, okay? I could say that angle 7 plus angle 6 equals 180 degrees, okay? And I can keep going, but if they're next to each other, then they add up to 180 degrees. So let's apply that, all right? And let's come over here and let's say, let's find the unknown angle for angle 1, okay? Now here's what I know. That if I take these two angles here, 4x plus 23 plus angle 1, I'm going to get 180. So if I do that, if I take 4x plus 23 and add angle 1, I'm going to get 180 degrees. Now, I don't know what the measure of this angle is here, but I do know that it has an x. So if I figure out what x is, I could plug it in, figure out what that is, and then solve for angle 1. But over here, you have this scenario here where this is 112 degrees and this is 6x plus 4. Now, because these two angles are vertical angles, meaning that they're across from each other, what I can then do is I can label them as congruent and set up an equation as 6x plus 4 is equal to 112. And I could solve this equation for x. All right, so let's do that. Let's go ahead and subtract 4 from both sides. All right, and I get that 6x is equal to 108. Now, if I take 108 and divide it by 6, I'm going to get that x is equal to 18. So let me divide both sides by 6. Okay, this divides out, and you're going to get that x is equal to 18. Okay, now that I figured out what x is, I can use that to come up here, substitute it in, and figure out what that is. So if I do 4 times 18 plus 23 plus angle 1, that's going to give me a total of 180 degrees. So let's do 4 times 18 first, and that's going to give me 72, plus 23 plus angle 1 is going to equal 180 degrees. Okay, so 72 plus 23 is... Oh man, 72 plus 23 is going to give me 95. All right, just wanted to double check on the calculator. All right, so 95 plus angle 1 is going to equal 180 degrees. Okay, so now what I can do is I can now subtract 95 from both sides and solve for angle 1. All right, and so 180 minus 95. All right, 180 minus 95 gives me 85. So angle 1 is equal to 85. All right. So here's what I got. And then I'm going to come over here to this picture real quick. All right. Angle 1 we got was 85 degrees. Now, knowing that this is 85 degrees, I also know that this angle over here is going to be 85 degrees. Okay. Now, we found out that this other angle here was 95 degrees. Therefore, this is 95 degrees, okay? So, remember, angles that are across from each other should be congruent. They should be the same measure. And if they're next to each other, they have to add up to 180, all right? And that's the idea. That's all we're doing. So, hope you enjoyed this video. I know it was a little long, but a lot of information. And we will use all of these concepts for the remainder of this unit. So it's really important that we know all these vocab words. All right, talk to you later. See you soon. Bye.